All right, awesome. Well, just to be timely, we'll go ahead and kick it off. Thanks again for joining. Super excited for you to be here today. Just for a quick reminder, this is a monthly webinar series that we are putting on here at Diagrid, specifically around our new product Diagrid Catalyst. And in this session specifically, we'll talk about building a multiplayer gaming application. I will caveat, Josh and I are very talented, but are not game designers. So please bear with us. There's probably going to be a little bit of experimentation happening. We wouldn't recommend necessarily taking this and running it in production, but I do think it showcases the product well and will hopefully get you excited about some of the things you can potentially build on Catalyst. So if at any point you have any questions, please feel free to interrupt us, drop them in the Q&A, or once again, just holler. Okay, so I'm gonna just move forward, kind of explain a little bit about what the agenda is today, and then Josh and I will do a quick introduction. So we'll do a quick Catalyst level setting, no more than 2 slides, quite literally 2 slides, just to kind of make sure everybody here understands what Catalyst as a product is and the problems that it solves. We'll also do an overview of the application itself. So we'll kind of talk a little bit about the Tetris solution, the overarching architecture, some of the requirements, and then how those requirements are essentially translated into things that Catalyst can help with. Josh is going to take us on a code tour. So this is really just going to be a deep dive into the Go and Python applications that actually make the Tetris app, solution feasible and viable. And then we'll basically go into Catalyst, right? What are the resources required from a Catalyst perspective for our code to be able to talk to in order to enable these scenarios? And then Josh will focus on some of the work he did around getting this running on Google Cloud. And he'll talk a little bit about some of the added experimentation that he did that kind of led to some new features being prioritized on the Catalyst side. And then we'll talk a little bit about the road ahead. So this is just going to be a quick slide with a couple of the main priority areas that we're focusing on for Catalyst to improve the product, and hopefully we'll do so with your feedback. And then we'll also have a Q&A for anyone that has additional questions that they weren't able to ask throughout the session. So quick introduction of myself, and then I'll pass it over to Josh. My name is Kendall Roden. I'm one of the product managers here at Diagrid. I was at Microsoft for around 7 years before joining Diagrid, and focused really on everything from working directly with customers on solution architectures to really incubating open source projects, which is how I got into the Dapr space. I worked on the container apps platform and am now one of the PMs for our Diagrid products, both Diagrid Conductor and Diagrid Catalyst, which we'll be talking about today. And Josh, if you want to do a quick intro.
Cool. Yeah. Hi, everyone. My name's Josh. I'm one of the open source engineers here at Diagrid. So I've got 7 years experience or so writing kind of open source software, particularly in the Kubernetes space. So previously I was working on projects like Cert Manager, but now I'm obviously at Diagrid, and I'm primarily working kind of most of my time on the open source Dapr project.
Okay, great. Well, I'm going to dive into a quick Catalyst overview as mentioned, and then we'll get going into the solution today. Okay, so quick Catalyst overview. So I wanted to sort of just start with reminding you why we created Catalyst as a product, right? It's a fairly new product that we launched a couple of months ago. And really, we recognized that in the cloud native space, there are several different challenges developers are facing today, right? Just writing distributed applications that are no longer kind of in a single process also introduces a lot of complexity, right? Whether it's convoluted and boilerplate code that you're consistently rewriting in order to handle some of the new challenges that arise around service invocation, state management, logging, tracing, right? A lot of these things, we see customers rewriting a lot of the same code over and over again to solve problems that have already been solved. There's also complex developer tool chains and rigid infrastructure lock-in, right? So having to make decisions on which libraries you're going to use to accomplish which objectives, which infrastructure services that you're going to deploy to, which infrastructure services you'll use for storing and managing state, like databases, pub sub brokers, right? And a lot of the times you have to make a pretty big decision upfront and make a big bet on these infrastructure platforms because your code's going to be talking directly to those services. So, that's typically a big investment on the customer side or on the developer side as they're starting to code against these infrastructure services that have been basically chosen and bet on upfront at the beginning of a project. And then ultimately all of this, right, the increased surface area of libraries, dependencies, and infrastructure services ultimately leads to less secure applications, right? You're now opening yourself up to potential vulnerabilities in these things. And wouldn't it be nice if we had something that simplified this experience and also provided us a little bit more flexibility in terms of how our application talks to underlying infrastructure? So, all these problems have really led to less reliable, less secure applications, and Catalyst is coming to really help alleviate some of these burdens and these pain points. So how does it do that? The way that I would describe Catalyst is that it's a consistent API layer through which your applications can interact with underlying infrastructure services. And what's really nice is that Catalyst even gives a level more of flexibility in that you can run these applications absolutely anywhere, right? So you could have an application running on GCP and another in AWS, or you could just choose to have a mixture of PaaS-based services in a given cloud provider, like Azure Functions, Azure Container Apps, a couple of Kubernetes instances. All of those can communicate across a single API layer hosted in, by Diagrid in Diagrid Catalyst, and then connect to the infrastructure that makes the most sense to solve the problems that you're trying to tackle. So today we provide basically 5 APIs that are hosted by us, completely in a serverless fashion, consumption-based. So request reply, publish, subscribe, workflow to be able to orchestrate across a series of actions that need to happen in a particular sequence. We have a key value API, which is used for key value state management, and then basically a bindings API, which allows you to connect to services and either react or respond to events. So by providing these in a hosted fashion, we really help alleviate some of that complexity when it comes to, I have to make this huge upfront decision around where my application's hosted or which services it uses. Instead, you have an API layer through which your developers can code against, and then really the infrastructure platform on which that code is running or what it's talking to becomes abstracted. And so, on top of providing that capability, really powered by the underlying Dapr open source project, we also provide additional capabilities like Diagrid managed infrastructure. So we know that customers and developers are gravitating toward less operational overhead, right? We want to build applications faster. How can we do that? We can avoid having to deploy and manage complex infrastructure services. So out of the box with Catalyst, you're able to actually use a Diagrid hosted message broker or database for key value pairs to eliminate that need to depend on, an operations team that goes and deploys this on a given cloud provider and then has to manage that. So these infrastructure services are also scalable and secured on the Diagrid Catalyst side. So that's Catalyst at 1,000 feet. Now we're really going to spend the rest of the 50 minutes that we have together focused specifically on the Tetris solution. So lots of code, lots of demos, and essentially no more slides after we do this next bit. Okay, so really where it's going to start is we have a multiplayer, application or gaming service. This means that essentially in order to start a Tetris game, right, most of us know it takes 2 players. We need at least 2 players to be able to compete against each other in order to see who wins. So in this case, we'll have 2 clients, right? These clients representing kind of player 1 and player 2. They'll be connecting over the internet to GCP, and then we essentially have a point of ingress there, which is just going to be a GCP load balancer. And then based on the path, right, based on the action that the client is trying to take, they'll be directed to one of 2 applications. So we have the user application, and really think of this as doing everything from user login to initiating the lobby where 2 users can join, and then it will essentially offload and redirect to the gaming service whenever we actually start a new gaming session. So the gaming app will receive, hey, I have 2 players. I'm going to initiate a new session. I'm going to allow them to play the game. And then essentially at the end of that, I'm going to publish the results of the game so that, the user app can update user profiles with, the outcome of the game, essentially. Both of these are going to be running on Cloud Run instances. So they are just containerized, server-side applications, but they are both serving up HTML and JavaScript for the front end. And then the front ends have established a long-lived connection to each of the clients through basically WebSockets. So that's how you'll see the updating of the actual game itself, the ticking, all of that will be happening, from the server side to the browser directly. So this is the fun part, this Catalyst API layer. So there's going to be a lot of needs that each of these applications have in order to actually implement the logic we just talked about. Everything from, user login management to session state for a given game to being able to publish an event whenever a game ends. All of this stuff, right, would typically require communicating to some sort of database, communicating to some sort of message broker. So in this case, we're going to use 3 APIs. And if I zoom out just a little bit, you should see this legend here, which should help quite a bit. And then we're going to decompose this. But essentially, the user app will make a couple of API calls to this Catalyst API layer. So using an agnostic API, the user's application will be able to retrieve things like the state of the lobby, right? Do I have one user that's already waiting to join a game? Great, I can check the lobby state. I can, find the second user and I can pair those together. Or maybe I have a new user that's initiating a new game session and is waiting for someone else. I need to store that state. And we can actually use the Diagrid key value store in order to do that. There's some other state capabilities that we're also going to implement on the user side. So for example, being able to retrieve and query the leaderboard state so that we can track historical data around game sessions. And then ultimately, it will also use some form of service invocation via Catalyst in order to essentially send the 2 users that are ready for a game to be registered to the game service, which will then register that game and start a new session. So I don't want to use this to describe all of this because we are going to break this down to make it very clear. Let's go ahead and dive into those slides. So I want us to look at the Tetris solution from end to end. And basically, like as a user, what's the simplest user flow that I'm going to take through this game? So one is I have to create an account. Once I create an account, I need to log in. I'm going to be able to view the all-time gaming leaderboard before I even initiate a gaming session, right? So I can kind of see what I'm up against, see my competition. Just for a little fun tidbit, if you are a Diagridian, which is what we call ourselves, Yaron and I are pretty competitive around air hockey. So Yaron would get to see that I beat him on almost every game we've ever played before he, asked me to play another one. So you can view the all-time leaderboard, and then you essentially have the ability to opt in to start a game. Now, if you're the first user to start the game, it'll basically wait for a second user to become available. When that user becomes available, we obviously use WebSockets to notify the client that it needs to redirect into a gaming session. We have the users playing the game. The reason this is a different color is because ultimately the game session itself is managed by a different application, and that's going to be the gaming service. And then basically that gaming service needs to have some way of communicating back to the user application that the results of the game so that the leaderboard can be updated. So should be fairly straightforward. I kind of want to translate this, like what does this look like in the world of Catalyst, just so that we're tracking and we can kind of layer on the capabilities. So we've already talked about, we have 2 applications. Now keep in mind the users in game application here on our left side could be running really on any platform, on premises, on your local machine. That's completely up to you. But obviously we have the Catalyst project that's going to be hosted by Diagrid. Now, within Catalyst, we have the concept of app IDs. Think of these as being identities which represent each and every microservice or application that you have running externally. So for the user's application, we will have a user's application ID. This will provide an application token through which the user's app can specifically talk to the Catalyst APIs. And then we'll have a secondary app ID for the game service, as each independent application should have its own unique Catalyst identity, which we see represented here. So we're going to kind of walk through for each one of these segments, what are the requirements and what API do we end up implementing to achieve that? Before I do, there are a couple questions. So one is, will the code be available in GitHub? The answer is yes. We'll most likely publish it later today or early tomorrow. So we will make sure that we send that out in our newsletter, but also, yes, it'll be available on GitHub at Diagrid Labs. So perfect. Okay, so let's dive into each one of these kind of segments, right? So create a user account, login. What are the requirements on the app side? Well, we need the ability to store user account data, and we need the ability to retrieve this data whenever a user's logging in so we can validate that their authentication credentials are accurate. So we can do this by implementing user state management on Catalyst. So we can call the state API, and we can essentially store and retrieve this user state. Now, where that user state is being implemented, we don't care, right? The application doesn't need to know about Redis or Cosmos DB or the Diagrid key value store. The underlying implementation is completely irrelevant for the developer. The main thing is that I have a consistent API surface for retrieving and managing this user state. And how do I make that call? I make that call into Catalyst using the application token provided via the app ID. Another part is we need the ability to persist historical game data and win and loss data, right? I want to know what my score is over time, what my new point total is whenever a game's completed. And then ultimately, we also want to be able to aggregate a view through which the UI can surface up this information in an efficient way. So we're basically going to use that same state management API in this case, because for the sake of demo, we're storing the user scores with their user profiles. And then we're also implementing the query API that allows you to query over a given state store in order to retrieve basically an aggregated data view. Then we have starting and joining a game session. So we need to be able to persist and retrieve the queue of players that are basically waiting for a game to be started or for an opponent to join. And we need an ability to start a new game session when 2 players are in the queue and ready. So the way that we're going to do this, we're going to use the state API, but instead we're going to call out to a different backing broker, right? We could use a different state store for this. So we'll use the V1 state API to manage lobby state. And then we're also going to use the service invocation API, which is essentially going to trigger the game app to start a new session. Now, what does that actually look like when the gaming session gets started? Well, the user application, if it has permissions to talk to the gaming application, will essentially call that V1 invoke endpoint. And we can see that the game app ID will then forward that request onto the gaming application wherever it's running based on the endpoint that's being specified, right? So in this case, I'm going to invoke the gaming app to register the game. And then we see that the gaming application on our left side, wherever it's running, will essentially receive that request as proxied through the Catalyst APIs. And then last but not least, we want to be able to see the results of a gaming session after it's completed. How do we do this? Well, the game service will initiate a publishing of messages via the PubSub API, and the user service will subscribe, right? And once again, it doesn't matter what infrastructure services we're using for any of this, we get the same exact API inventory here. So I hope that at least gives you like a bit of a flavor. Hopefully, Josh, that sets up the code walkthrough a little bit more simply, but it really helps you understand from end to end, what are the requirements we have? How can we implement them in a super easy way using Catalyst? And then basically, how can we really get that language agnosticism and also simplify the number of libraries we need to accomplish this, as we can basically use, Catalyst specifically in order to accomplish these objectives. So what I'm going to do now is I'm just going to show you the application up and running end to end so that you just get a flavor for the workload itself. And then what we'll do from there is we'll kind of dive into what are the Catalyst resources. So we already kind of talked about the app IDs, but what are some of the other things we need to configure in order to enable that kind of infrastructure abstraction layer. So where I'm going to start us is in the Google Cloud Console. Once again, we're not going to walk through the cloud deployment yet. We're just going to show you the application running so that you get a good feel for, what does this actually look like in practice. Okay, so I'm already logged in as Kindle Rodin 1. I'm going to go ahead and log out just to start us from a fresh perspective and get that full end-to-end walkthrough that we just mentioned. And not only that, I'm also going to open an incognito window because in this case, because I'm so talented at Tetris, I'm actually going to be playing as 2 people. I know, shocking, but I'm very good at this. So what I'm going to do, open an incognito window just to kind of emulate essentially the 2 players. So let's say I'm player 1. The first thing I'm going to do is I'm going to sign up. So we have this generated. I'm going to go ahead and make this a little bit more readable just since we know we're getting started here. And I'll just say, demo 1. I'll give it a password and I will sign up. So user 1 has signed up. They're taken to the leaderboard where they can kind of see, once again, that historical data over time. And then they can essentially opt into to start a game. Now, in this case, they would be, oh, we love when Zoom does the automatic thumbs up. It's good affirmation. So I can start a game here. This is obviously not going to start a new session because there is no one in the lobby or in the queue waiting to join. So what this would do is it would actually store state in the Diagrid state store that says, hey, Kindle Rodin 1, demo 1 is waiting in the lobby for a new user to join. And then we're going to sign up with a second user. In this case, we'll do Kindle demo 2, and then we're going to give it a super secure password here, 1, 2, 3, 4, 5, 6, 7, 8. Not really, but something close to that. And then we will sign up. Okay, so I have 2 users. Fingers crossed. Now, once again, like I said, Josh and I are not big game developers, and we put this together. It should allow us to opt in to start a new game. It's waiting for another player to join. Okay, so demo god's not super nice to us on the first go around. That's okay. We're going to do a hard refresh and we're going to try again. Fingers crossed. Okay. Not the funnest thing to happen, but Josh, do you have any like clear thoughts other than just us why this might be giving us challenge?
Ooh. No, I'm not
Yeah,
too sure.
I'm not sure. Okay, that's okay. We're gonna keep going, but we are gonna show this locally, and then I'm gonna let Josh, take it away. But essentially, what should happen here? I start a new game, another player logs in. I might even try logging out just to give us one more, good run at this. And once again, we tested a million times, but when you're doing it live, you can just never be too sure. Okay, we will log in. We're gonna try this one more time. Fingers crossed. I also have 4 incognitos open, so let me try one more thing, because we love a live debug, which is what most of us end up doing anyways, is debugging stuff. Let me see if I can. Ooh. Do the same on this side. Okay. Okay, I'm gonna leave it here. I don't wanna bore us, but we will see it working. I guarantee it. I guarantee we'll see it working by the end of the session. But ultimately, what would happen is you'd see the Tetris board at this point. We would finish the game, and then you'd see the scores update. So hopefully, when we walk through this, locally, we'll see that happen, and then we'll try again with GCP. So yeah, apologies everyone that didn't work on the first try, but once again, demo gods are typically finicky beings. Okay, so we've walked through this. What I'm going to do is show you the Catalyst setup. So I'm going to basically take you to Diagrid Catalyst, and I'm going to show you what are the resources that are needed in order to enable this scenario. So Josh is going to walk you through the code, but I really want to talk about that like Catalyst API layer. So we already saw in the slides that we're going to have 2 app IDs. When we click in on an app ID, we see some pretty interesting things. So one is going to be, we see that there's an API token. This is what the gaming service, your application, will use in order to broker and facilitate a connection to the Catalyst platform in order to do things like publishing of messages, invoking other services, storing and managing state, all that good stuff. And then we also have one for the user's app, because once again, this is going to be a unique API token, which is going to help establish that one-to-one connectivity between your application and Diagrid Cloud. So once you have these available, what else is needed in order to enable these APIs and get them up and running? So we have this concept of connections. If you're coming from the Dapr world, it'll definitely feel pretty similar to components. We felt like connections in the case of Catalyst would be a better indication of what they're actually doing, which is connecting you to another service, right? Whether that service is running and hosted by Diagrid or is hosted externally. So in this case, we have a couple of connections that are going to be needed in order to enable this scenario. So one of them is going to be the user scores component. This is going to be a state component, which means it's used with the state API, and it's targeting a Redis instance. So I've actually deployed a Redis instance to, just like a free Redis instance in the cloud that's essentially being run for me. And that's what I'm connecting to. So I'm using this service. Once again, I could swap this out for Cosmos. I could swap it out for Azure Redis. It's 100% up to you and what makes sense for your particular use case. We can click in here and we can see a couple of the connection details. So we can see that we have the Redis host pointing at this Redis Cloud Console. And then we also have the Redis password, which is what's enabling that connectivity. And then another interesting thing, we talked about using the query API in order to show the scoreboard. So we can see here, this is the query that I'm actually passing in order to retrieve the leaderboard data, basically with user and their overall point total. A couple of other things, we have the score pub sub, also using that same Redis console instance, but once again, could be swapped out for, Azure Service Bus, Diagrid pub sub, whatever your heart's content. And you can see I'm passing in that same Redis host and the password. So this is going to allow me to use Redis streams. Now, that's great that I have a pub sub broker, and this is going to be used specifically for the game service to publish when the game ends and send historical data back to the user service. but the user service needs to be able to listen. So we do that via a subscription. So we can see here that we have a single subscription called Score Pub Sub. And basically what it's going to do is when any new score update is published by the game service to this topic, it's going to be routed to the update score method within the user app, which is basically going to update the new user score and then run the new leaderboard query. All right. And then last but not least, we actually are using the Diagrid key value store in order to manage the lobby state. But we could technically have used the same Redis instance. Really, the goal there is just to show, if we didn't want to use Redis in this case, we could just, rely on the out-of-the-box services provided by Diagrid Catalyst. All right, awesome. So, I mean, it's that simple. That's pretty much all it takes in order to get up and running, right? Create a couple of app IDs, create your connection, and then ultimately create your subscription. And the last thing I'll show here is that depending on what your connection is, right, you can select a connection type, and then you'll basically see that we have a variety of different backing services that are used. So really removing this dependency from your application code and giving you that consistent API layer with a series of features on top, like, observability, resiliency, all that good stuff. And you can also even import an existing Dapr manifest. So I know there was a question about, how is this compatible with Dapr? We basically will take a Dapr open source component manifest and translate it into a Diagrid connection on your behalf. And ultimately, when a connection is created, you also have the option to essentially export either the Catalyst declarative format, or you can, export this to a Dapr manifest if you were to kind of be moving in and out of the two platforms. Okay, cool. So that's what I wanted to show you on the Catalyst side. Now I'm going to pass it over to Josh for him to kind of deep dive into the code and actually show you how the APIs are configured. And then we'll recircle back and hopefully get that demo working for everybody, who's excited to see it in action.
Awesome. Yes. So as we've been describing, we have two main services here, which are implementing this multiplayer Tetris game. We've got the user service, which is a Python application, and the game service. So both of these are web services. They're serving, various HTML and JavaScript. So that they live in this kind of static directory here in the case of the game service. So there's got some JavaScript in here, even templates has got some HTML in here. This is obviously rendering out all of those pages that Kendall was showing earlier with the kind of login page and things like this. Fairly standard kind of HTML type stuff. We do have some WebSockets going on, implemented through Socket.io. That's to bring up the kind of waiting for other players and things like this. I think someone else asked in the Q&A whether these WebSockets were going through Catalyst. No, this is just kind of going over the internet as a normal kind of client to server communication. Catalyst is purely on that kind of backend side, implementing our APIs. So yeah, let's go ahead and look at the user service Python code. The first thing I wanted to shout out was how we are connecting to Catalyst. So Catalyst provides these APIs. These are the kind of Dapr kind of compliant APIs, meaning that we can use the kind of normal Dapr SDKs in order to communicate with Catalyst. So if people familiar with Dapr will kind of feel very familiar with using Catalyst as well. And so the kind of Python-y way of using the Dapr SDK is to use this kind of paradigm of with Dapr client. And the first thing I wanted to kind of point out was we're getting some state here. So you can see here that if we don't have a session yet, when you kind of go onto our normal kind of the base kind of index page, it's going to send us to the login. And then we'll kind of do the login flow. In fact, we can look at that next. You can see here that we're kind of using like a basic kind of form submission. And once that form submission is done, again, Dapr SDK, we're going to save that state in the state store. And so the way we're doing that on the back end, this is, as Kendall described, Redis. But for the kind of application developer, from kind of our perspective right now, we're just kind of saving this JSON object to this particular key I believe we're using some kind of username, I think, is our index. Yeah, using our username here. And we're kind of giving it the password. So this is the kind of hashed password, and then giving it kind of the default, no games played yet, that kind of thing. And then we're saving it in our kind of session context, the username, so that we have that kind of session going on, and we're kind of logged in. This is a Flask application, so we're using a lot of those kind of Flask primitives that you get in Python to manage a lot of this kind of login sessions and things like this. So that's us saving the state for a user, and then it's the case in, for example, when we go back to our home, which is what we're looking at just now, we're kind of getting the kind of user state. Here we are showing off the leaderboard. So if we go to the leaderboard page, we can see here all of the users and how many games they played, how many wins, and things like this. In order to get that information, the user's Python application is doing a query over that the kind of keys in the Redis database. So this query is living inside the in the Catalyst connection, and that query is obviously sorting the list of users by number of wins, and then sending that off into our HTML templating and kind of your usual kind of internety stuff. The other thing that I wanted to point out was when we do a start game. So as you saw, if I click this start game here, it's going to wait for another player to join. What we're doing here is we are using the default self-managed KV store supplier kind of provided by Catalyst, as a kind of very small kind of KV store, kind of single key to use as a kind of waiting lobby. Obviously, we need 2 players to start a game, so we just kind of save to this key that this person is waiting, and then when the kind of next person clicks that button, it's going to check that key. If it doesn't already exist, then it saves the key. If it does exist, then we know that we've got 2 players that are ready to play a game. Once it's successful, and we do have 2 players waiting for the game. So this is when we have 1 player waiting for the game, and then we have 2. It will then it will send a service invocation API to our game service, which is that Go service that we'll kind of look at in a little bit. So this is what this register game function is doing. Let's see if we can pull that up. Yeah, that's where it is here. And we can see here that we're doing a service invocation. So we're just sending a message basically to our game service. We're saying these 2 people these 2 players want to play a game. And then it's going to send us back a session ID. And that's what we're going to use, and as well as a redirect URL. And we're going to use that to redirect these 2 players. So once we've got that redirect URL, it's going to emit that redirect to our 2 clients on the page. And again, we're using WebSockets here, so that's how we're getting that kind of bidirectional messaging. And then, yeah, it's just going to simply redirect those 2 players over to the game service. So that's what that is doing. Also, to mention the last thing is the pub sub part of this, right? So after 2 players have completed their game, the game service then needs to do something with the result of that game, right? So people scored some points, someone hopefully won. And so in order to pass that data back from the game service onto our user service, because you remember it's the user service which is writing the kind of user state to the database and querying what the leaderboard is and things like this. We have a simple HTTP server here, which is receiving those pub sub messages. You can see here that we're kind of pulling out that JSON blob and then writing it to our update score function. If we go to our update score function, it will be then updating the database with the results of those games. So it will grab the two players and it'll say whether they won or not, and kind of increase that number by 1 and their points by the number of points that they won. And this is it. This is the whole user service. This is all the Python we need, and then yeah, we have all of those HTML and kind of JavaScript pieces written as well. If we go over to our game service and open up main.go, yeah, like I mentioned, the game service is written in Go, and when we get to so to kind of follow on with the service invocation piece. Let me get that. We were just talking about that. You can see here that we have another HTTP server, and that is receiving this kind of register game. So that was that service invocation request. So that's going to end up hitting this. This is going through Catalyst, remember. So the user service is talking to the user's app ID, and that's doing a service invocation to the game app ID, and that's then getting sent to this Go application here on this endpoint. And just like we saw before, this is going to grab the two users that are in the waiting lobby, ready to play a game. It's then going to create a session ID for them. So we obviously need a unique ID per game session to kind of keep track of all the different games that are going on at the same time. And then it's going to build some internal state that we need for that session and then reply back. So this is the other side of that you saw from that redirects URL. This is the bit where it's actually building that string. So that's the redirects URL piece. Then it's for the game itself. So we'll kind of see how that's working in a second. You'll see, we have two kind of Tetris games going on at the same time. Again, this is heavily using WebSockets. The game itself is all written in JavaScript. So if we go to, I believe it's in assets, right? So the kind of top level. So we're using a JavaScript library called P5.js, which is kind of a like a bit of a kind of graphics library that's kind of easy to use. You can draw boxes and things like this. So that's what we're using there, and then using those WebSockets to send our current board state to the server, and then similarly kind of retrieving our opponent's board state as well. So when you have it on your screen, you'll see kind of two boards playing at the same time. Again, we're not game developers, so likely not played in the best way. We'll say that the kind of game itself is quite latency sensitive, I suppose. When you're the way that it's been coded, it's kind of doing these ticks, right, where every tick is kind of moving the board state forward. During each board state, or each tick rather, the client is sending the board state to the server, and then the server is sending it back. And so it can kind of get quite sluggish if you're kind of quite far away from the servers, or one of the opponents is far away from the server. So yeah, we've kind of got it currently deployed in US East, which is very far away from me. I'm in London, so it has to go through over the Atlantic a couple of times. So games are a bit slower for me. But yeah, that's just kind of how it's coded. Good. So yeah, this is kind of JavaScript application that your browser is downloaded, and you're sending messages backwards and forwards to the game service. And there are various kind of socket IO handlers in here that is keeping track of, for example, if we go to the I believe it's this ready handler here, which is ticking the game forward and sending board state backwards and forwards between the two players. The important bit for us is what happens when someone wins, right? So I was just describing about that pub sub piece. So we need to send the information about who won back to the user service, right? And we're doing that through pub sub. So that's that piece here. And we're just kind of doing a client.publish event, and we're sending it to a particular connection, and then we're sending it at this topic here, which is what the user service is subscribing to. And that was the piece that we showed before, and we're just saying who won and the score and things like that. Great. So and then that's it. That's all we need. We have this deployed in GCP, as Kendall mentioned. In fact, we can kind of give it a go here. Is this going to work for me? It did work.
Yay! Nice.
Great. You can see for me, the game is very, very slow because, as I mentioned before, yes, this is deployed in US East, I think it is. And due to the way that kind of tick behavior has been written, that we kind of have to do like 4 hops, I think, across the Atlantic to for every tick. So it's very, very slow. I think a way to improve this would be to queue up those ticks, so the 2 players are playing on 2 different tick rates, and just being optimistic, and then the game service basically having a queue of ticks that it can send to a client on what their ball state would be. That's the lag compensation, I think, might be the right word to use. But yeah, again, I'm not a game designer, and so this was kind of just put together as is naively. As you can imagine, local host, it works very quickly, and it's all good. To go to the actual publicly deployed, as you can see, this is public DNS, and this is running on tetris.joshvanal.dev. You can indeed go and visit that domain in your browser, and it should bring up the same thing. So the first thing we need to do is obviously deploy these services. So as Kendall mentioned, these have been containerized. So when I wanted to deploy these applications to GCP, I didn't want to have, if you remember correctly, the kind of service invocation HTTP server, as well as the user's pub sub subscriber HTTP server. I didn't want to expose those over the internet. So Catalyst has a mechanism for creating a tunnel to an application ID via the CLI. So what I did was build a container with the game service and build a container for the user service. And I also bundled in that Diagrid CLI as well. So when I'm running that container, it's also going to spin up a tunnel, which means that I can keep those kind of 2 HTTP servers, of a private network, and then only expose the kind of the actual public game itself. So that's how that piece has been built, and this is deployed, pushed up to GCP. I then give it a few environment variables. So you're probably wondering, how are we connecting to Catalyst? I'm using Dapr SDKs. How's that working? So the way that is working, so I give it an API key. That's for the Diagrid CLI piece. And then I point it to a project. So that's just getting piped through into a script, as well as the URL. And that's all I need. Whatever combination of this would then, work for another project on another person's account. But that's all the configuration I need to get this container running with Catalyst and authenticated and using the right resources, etc. Then it's a case, just exposing it on port 5000 in this particular case for the user service. For the game service, if we pull this up quickly, this is exposed on 8000. Again, it's just a built container. It's the variables we want to look at. This one here. We have some kind of application specific to the game host and lobby host. This is needed just so that this by default would be local host, right? So we can kind of play the game locally. And this is to do with that redirect URL that we saw before. And again, much the same. We give it an API key and a project. And that's all the configuration we need. So they get then run in my GCP Cloud Run. In GCP Cloud Run, and then I need to expose this on the internet. So I created just a very basic, a classic application load balancer, as GCP calls it, which has a public IP and HTTPS, so it gets a certificate, and then we do some simple HTTP path routing in order to send URLs to the right places. So by default, we send everything to Tetris users, which refers to the users Cloud Run service, and then paths on the /Tetris and /game get sent to the game service. So we use the same domain, it's the same IP, and then we just route to those 2 different microservices based on the path. Pretty standard kind of websitey stuff, microservicey stuff. And I think that's everything. What do you think, Kendall? Should I pass back, or?
Yeah, no, I think that sounds good. Does anybody, let's see, there's some Q&A, but I don't think any of it's, let's just answer a couple of these. It looks like maybe there's one here, which is, where is it? Oh, it looks like all of them have been answered. Way to go, Josh. Oh, I'm in that answered column. That's hilarious. Okay, so if we're looking at open, let's see.
Mhm.
Can more than one instance of the app be created? Definitely. Yeah. So you can definitely have more than one instance of your application, right? If your application is getting scaled up, you can definitely have more than one instance of that running, and it will still connect to the Catalyst APIs. Then it says, does Catalyst have private network peering ability? Let's say I have my own Redis cluster running on Azure with only private VNet access. So this was another question that we were going to answer just kind of on like the future roadmap. So what we're planning on doing really at first is private link. Or actually, I mean, Josh, I'm sure you could answer this, but just in a high level summary, right? Our goal is to basically create an ability for you to privately connect to applications because today, oh, this is one thing we didn't actually cover, which Josh might be fun to talk about. Maybe I'll show the dev tunnel connection first, and then we can just explain that part. But essentially, yes, we're working on like private link connectivity from an app ID to the application workload, right? If you have a subscriber that needs to receive messages and you don't want that to happen over a public endpoint. And then we'll also have, our goal long term is to also have like private connectivity from, connections basically through an identity to be able to connect to your cloud hosted resources. And Josh is working on a lot of this, so I'm sure he can answer a lot more in depth for you, but I think at a high level that probably covers the long-term vision. Today there's not the private peering, but the goal is that we'll have that private network connectivity. We're actually working on it. um, Okay, which DB are we using here? So in the case of what Josh showed, he's using that free Redis, the same thing that I showed earlier when I was sharing my screen and I said, like, I deployed this Redis database. He has all the same Catalyst resources deployed, right? So when he's talking to the state store, he just passes in the name of the connection. And then regardless of what the backend infrastructure is, it'll broker and facilitate that. So we're using Redis in this case, but ultimately, right, it could be whatever backend that you want that's supported by Catalyst, and you'd access it the
Mhm.
same way.
Yeah, exactly. The only one difference was that the game lobby piece. So if I click start game, it's writing to the Catalyst managed KV store that it comes with by default, just as like a single key kind of optimistic lock kind of situation there. But yeah, but most of it is writing to that Redis.
And then Nathan, you said is the tunnel outgoing tunnel the one that, and Josh, I honestly may have missed this, but did you touch on the fact that you deployed it with the dev tunnel?
Yes.
Okay.
Yeah.
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 So Nathan, you're correct. Actually, it's specifically that tunnel is so that the Catalyst resources can talk to your app, right? So when we're talking to Catalyst right now, it's just happening all over the public internet. There's no private tunnel there, right? We're just making calls to the state API with the API token. Whenever the connection is being established from a tunnel perspective, that's so that events that are coming from Catalyst can be delivered back to your application on a private endpoint.
Yeah, exactly. Yeah. So that's this piece here that I'm showing on the screen.
Yeah.
That Diagrid login with the API key, and then what project that I want to use, and then Diagrid dev start is that tunnel piece. So yeah, and then spins up the game.
And then there was a question, do you only have a server for WebSockets or are you able to scale horizontally? Josh, that was a question that came in.
Gosh, I do not know. That'd be a fun exercise to try. I'm not too sure. I'm not too sure what would happen. I want to say that the user service, I think for sure can be scaled horizontally. The game service, I'm not too sure. I think that might have some problems with some local versus kind of universal session state. So I'm not sure the game service. I think we need some changes. But yes, the scoreboard definitely improved and made a bit better. Yeah.
There was another question. How does Catalyst compare to Service Fabric in terms of data storage? So I can't speak 100% way into like, I want to make sure I'm being, coming back to like the main point, but I can at least explain how it works in Catalyst and maybe, how it doesn't work similar to like a cluster type of like orchestrator engine, right? So like Catalyst really, its only goal is providing this, API pass through. Now we happen to have a database that we provide, like a managed database that you can use to store data, but it's not like any kind of like file mount or like a persistent volume in Kubernetes, right? It's really like a hosted database service, similar to any other like cloud provided hosted sort of like SaaS based database. So we aren't doing any kind of like data storage on, in terms of like local persistence or your app mounting to anything. So hopefully that at least helps. I know Service Fabric is comparable in the sense that it's like cluster based and you're running on a set of nodes similar to Kubernetes, but we don't really have any data storage, I would say, that's similar to what you would get in a Service Fabric type model, because your workflow still could potentially be running on like a Service Fabric, right? So the hosting platform of your choice where the app is running is completely up to you. This is more for connectivity to a database that might be storing, particular state without having to talk directly to it like a Redis or a Cosmos. Okay, cool. So I think that's most of the questions. We only have 4 minutes left. The only thing I was just going to touch on, and this is just something to be aware of, and Josh, if you don't mind stopping the screen share just so I can show this pretty
Yeah,
briefly.
absolutely.
Cool, thank you. So the last thing I'll share, and once again, feel free to drop more questions in if there are some, and we can kind of, we can focus on those. But y'all can see my screen, I think.
Yep, we can see your screen.
Okay. So I just wanted to call out. So like Josh did this really cool thing, right? Where he basically compiled the Diagrid CLI into the container and then basically created that like tunnel proxy. The way that you can do this locally. So like, let's just say I have like, the 2 applications that Josh was running through. Unlike him, I use VS Code and not just Vim for navigating files because I'm a normal person. I'm very impressed by that, by the way. That's not a knock. I'm very impressed. I could not do it. So like, let's just say you have your 2 applications, you have your Go application, you have your Python application. If you wanted to connect these to Catalyst, like we talked about how, Josh did a good job explaining, basically, we're using the Dapr client, and the Dapr client is essentially expecting a certain set of environment variables, which you saw in Cloud Run, to connect back up to the Catalyst project. What you can do is you can basically do, and let me just delete this really quick, just for the sake of showing you how it works. But I'm logged into my like Diagrid project. So if I just do this, like I can see I'm in the project I've created that has all of the resources. I have my URL. I have, all my app IDs, connections, all this good stuff. If I want to connect local apps to that, I still need some kind of like local proxy, right? Because I don't have a public endpoint running on my machine. So ultimately I need Catalyst to be able to communicate back for like subscriptions and service invocation forwarding to, the locally running apps. So we created this Diagrid dev scaffold command. Basically what this will do is it will scaffold for you a file that basically references the 2 app IDs I've created, and then also essentially sets the environment variables that the Dapr SDK needs to connect to the hosted sidecar or the Catalyst app ID. And then basically I can populate it with the port that my application is running on, and then the command that I need to fire the app off. So you can see here, I've done that, right? I've just basically added port, 80,001 and then, or 8,001, and then the app port 6,003 for the user's app, and then basically the command to launch both of the applications and where the code is sitting. So fairly straightforward, but when I do a Diagrid dev start, what this is going to do is if there's a port there, it's going to establish both it's going to establish that local, development tunnel for me. So I can just like pass in the name of this dev file. And what this is going to do, it's going to fire off both apps so I can see like my app logs. And then it's also going to start the app ID connections. And you can see like it's connected from Catalyst to our local machine. And if we look at the Catalyst project, give me 1 second here. If we look at the project, we can actually see that the apps are being redirected by looking at the this area, right? It says app connection, and it tells me that it's pointing out my local machine. So that's how I know basically that a dev tunnel has been opened. And then I can basically go through the same exercise like Josh did, right, in the cloud, but instead I can like create a new log, right? I can create a new sign in. And all of this, once again, is completely running on my local machine, and it's using the Catalyst APIs for PubSub and state and all that good stuff. And we can see that we have, our leaderboard, and then we can essentially start a game, and I could, open up another tab and start that session and go through that same experiment that we did in GCP, but using the local proxy to do more like development related work. So this is how you're able to kind of connect to, the Redis using that abstracted API without actually having to, run, Dapr locally or any other, primitive locally. We're just opening that connection. So just kind of wanted to show you that little tidbit so that you would know. And then basically what Josh did is just package this up to make the deployment private. But ultimately, the long-term vision for that is the private endpoint. And it does look like there are 2 more questions that maybe came through. Just one. What are the use cases we can use Catalyst? Most of our apps use RDBMS or NoSQL databases. Well, great. Well, we have support for NoSQL databases. So we just need to talk basically about what your particular use cases are, but you can definitely use Catalyst for NoSQL databases, right? We have support for things like Cosmos. And I believe there's a couple of other NoSQL databases, other document DBs that we support. So definitely sign up for the private preview. If you haven't already done that, we would love for all of you to engage, play around with the app, build your own apps. But if you have questions around particular use cases or databases that are supported, we're also happy to chat about that. And it's documented in our documentation as well. So yeah, we're at time. Thanks so much. Thanks, Josh, for the great work putting this together. Thanks everyone for the engagement, the questions. We're super excited for where this is going to go, and we'd love your feedback as we continue building out the product. So yeah, with that, have a great rest of your morning or evening, depending on where you are.